Right, here we go. Thank you very much, Chris. So today I'm going to be talking about the urban design for cleaner air. I'm from the University of Birmingham. Well, first of all, there's two projects that support for some of the materials I'm talking about, and a large number of people have contributed to the presentation material. What I'm going to talk about is three main areas. First is the state of the air, what is the impact, where we are, and what are the challenges. And then I'll talk a little bit about the four small areas that urban design could be adapted or considered to help us to improve air quality or reduce exposure of people and protect human health. And finally, talk a little bit about how do we avoid unanticipated consequences while we are making those, while we're designing those urban landscapes. So first of all, yeah, we have been seeing a huge improvement in air quality. So on the left side, you can see that in the UK. Let's just see most of the places where we will be living is called urban background. And we can see the nitrogen dioxide pollution levels has been reduced by more than 50% in the last 30 years. And it has also been continually improving in the UK. So this is a major achievement we have to recognize first. And what even more dramatic is the huge improvement in PM 2.5 air quality in China. And this is an example given in Beijing. In merely 5 years, they have been able to improve the air quality by PM 2.5 air quality by 32%, which is really impressive. Now, but where we are in terms of the air quality globally, so this one is showing the annual population weighted PM 2.5 concentration in different countries. What you can see here in some of those most polluted countries, India and Nigeria, for example, you can see really high levels, 75 to 85. And what we're talking about, this is 25 times more than the annual average values of the air quality guidelines by the new by WHO in 2021. Now, if you look for some of those other polluted countries like China, it's still really high levels of pollution. Even in those more remote places, the pollution level is still very high. But what's really astonishing when you look at the numbers is 99% of the world population was living in places where the WHO air quality guideline levels were not met. So that is 99%. Now, what about the air pollution in the UK, where most of us are on this call are here? This is the nitrogen dioxide levels. It's again an annual average. So the new air quality guidelines by the WHO suggest is less than 10 microgram per cubic meter. So this is this color here. But if you look for those urban areas in the UK, a majority of those are way above these levels. We have seen a huge improvement in nitrogen dioxide, and actually the nitrogen dioxide pollution levels in most of the cities, except some of the roadsides, are actually within our legal limit, which is 40 microgram per cubic meter. But we are way above the WHO new guidelines, particularly for those populated cities. PM 2.5 even worse. So if you look at this one here, this is the color where we see PM 2.5 levels is less than 5 microgram per cubic meter, which is the new guidelines by the WHO. And if you look at those in the southeast of England, the pollution levels is much, much higher. And if you look at the population, if you are talking about even in the UK, which we know is, the air pollution levels is relatively low, we're talking about 90% of the population is living in the areas with PM 2.5 levels over the WHO guidelines. And this is the roadside nitrogen dioxide levels, which you can see really is those roadside, which are the biggest challenge they are facing now. Now, what is the impact? We now know that air pollution is the fourth largest causes of death globally. And if you look at those in the UK, air pollution is the biggest environmental threat to human health, and with 28,000 to 36,000 deaths per year attributed to long-term air pollution. So there's a huge impact on human health, but also there's a huge impact on the economy, which I haven't listed here. So there are some things that we could do from an urban design point of view to help us to improve air quality. The urban design affects air quality by affecting the pollution emission, by affecting the dispersion of pollution from the sources to people, to receptor side where people are living or working, and by affecting their personal exposure. Now, most of the cases we are talking about now is the urban design is not connected with the air quality strategy. So when we're thinking about urban design, we don't consider air quality, and that could have a disbenefit sometimes if you didn't consider those effects. What we need to do is to integrate air quality thinking into planning and design to reduce emissions, to extend the distance between the sources of pollution to the receptor, and to protect people. Now, road use is one of the major sources of air pollution in the UK and in many of the developed countries. And what you can see, this is the West Midlands, where you can see the simulated nitrogen dioxide levels, and this is the simulated PM 2.5 concentrations. What you can clearly see is those huge influences from those road networks, the PM 2.5 as well. The contribution of road traffic to nitrogen dioxide, nitrogen oxide, which is the main pollutant in the UK, is about 50%. Of course, we have other sources like aviation, industry, and construction, domestic heating, etc., etc. But the single most important source is from the road traffic, because this is the data from London, and other cities are relatively similar. And within those, we are talking about the vans, the minibuses, HGVs, and this is London, which may not be the same in other cities, but what you can generally see is diesel cars are really important sources, minivans, the HGVs, the buses. They contribute a lot to the pollution, nitrogen dioxide pollution emission. Now, the COVID lockdown has clearly reduced air pollution, and we know that the primary impact is through the reduced traffic in the cities. And here's the example where the reduced pollution levels have immediately after the lockdown began in our cities. We can see this is the measured data, and this is what we're using a machine learning model to simulate the real weather normalized concentrations, and you can see the sudden changes when the lockdown was in place. So by reducing the road traffic, we have clearly see the drop in nitrogen dioxide levels in our air. But we should also not forget that you also have the 50% of the other sources of pollution that has also needs to be taken into account. And we were initially expecting much bigger drops in pollution levels, but our study has confirmed that it's not as big as we expected. And if you consider that actually the road traffic only contribute about 50%, well, not only contribute, it's contribute about 50%, not 100%. This is something that, and it becomes more understandable. Now, the UK has its road to zero strategy, and we are starting to study and investigate those impact for on air quality. And what we do know clearly is that the road to zero strategy has air quality co-benefit. This is, again, it's in the Birmingham area. What we looked at is the impact of bus electrification plus 50% of light vehicle electrification. What we can see here is, probably focusing on this one here, is we can see a major decrease in the nitrogen dioxide levels if we changed 50% of our light vehicles to electrical vehicles and to electrify our bus fleet. This is some preliminary data, and what you can clearly see the benefits is in those road network, but you also can see in this urban background, you can still see substantial benefits. But electric vehicles is not really the final solution. Electric vehicles is not zero emission. You might often see the manufacturers say this is a zero emission cars. It's not the case, because the EV still emit land exhaust particles. You can probably understand that reasonably easily, because every few years you have to change your tire, and where does those tires have gone? The tire has become little tiny microplastic particles get into the air, and some of which will be breathed into our body. It shows the emission inventory. We need to be careful, which is because it has some a lot of uncertainties here. What we can see here, this is the yellow part, is the exhaust particles, but we can see those, the tire wear, brick wear, or road abrasion, they're having generally an increased trend, which is primarily because the road traffic has been increasing over the years. Now, the exhaust particles make a small contribution now, but you can see the huge contribution from the land exhaust emissions, and this has health implications. What we really have to do is to prioritize cycling, walking, and public transport and reduce the mileage. And unless we do that, we're not going to really have the kind of clean air we want. And on the other hand, the EV does use electricity, and it does needs more energy to produce. So it's not zero emission, because when the EV is delivered to your home, it has already produced a huge amount of greenhouse gases and air pollutants. Another area I would like to talk about is the street kenning. This is the Google, from Google, actually really clear. And this is the Marylebone Road air pollution super site. I think this is probably somewhere in Madam Tussauds as well. Some of you might have been there. And you can see this is just clearly a street kenning where you have buildings at both sides, pretty much almost the same same height. And I explained to you why that is not very good. Marylebone Road is one of the most polluted places in the UK, and that's primarily because of road traffic and because of those design of those street kenning. So what happened is, if you got a straight canning here, let's say this is the distance, this is the street, this is the buildings, and when you got the cleaner air from the top, and it creates some kind of turbulence, a vortex here, and if depending on the relative height of the buildings and the width of the road, this could happen is where you got the clean air come here and then blowing those polluted air from the traffic to the receptor side. If you're living on this side of the building or this side of the road, or you're walking on those sides of the road, the pollution level could be many times higher than you're living on the other side. So if you have a consistent prevailing wind and you're living on the other side, you're very unlucky. And this is another modeling that's done by our research group in Birmingham, is that if you look at the pollution here is, you've got air comes in here and the air will start to create turbulences, and that really affects the distribution of air pollution. So by adjusting the height in the model world, you can actually see what is that the impact, and depending on the relative height of the two buildings and the relative width, we can actually see that under certain conditions, the pollution levels are much lower when you're comparing to other conditions. For example, in this case, is if your lightning wind is come from this direction, this is much higher, this is lower. What you're really getting is huge pollution accumulation on the surfaces. On the other hand, if you're in this kind of a setting, what you can see here, the pollution level becomes much lower. And if you adjust the width of the road, and you can also see clear benefit of those, if you reduce the road, you can see the NOx concentrations at the 1.5 meters to be much, much higher in comparison to a wider road. So the street geometry, we know that it has a huge impact on the air quality, and we really need to consider those while we're designing our streets. And in general, is the more rough surfaces, the better for air quality. And it can also deliver co-benefits to urban heat, and urban heat island is a problem, particularly in those warmer regions. And in the high building scenario, what you can see, the heat is essentially trapped, and you're having a really high temperature on a straight canning. But if you start to make that different height, you can start to see the turbulence being generated, and starts to dissipate the heat and make it more comfortable to live. And we have also did some observations to show that the urban green spaces have clean air, which is not surprising. Everyone would probably know that. So what we did is we make measurements at the roadside, and we make a range of measurements near the at different parts of the university where it's much greener. And essentially a few meters, probably 5 to 10 meters away from the road, we start to see the pollution levels goes down close to the background concentrations. When you get to but you're really living close to the road, that has become a problem where the pollution levels could be much, much higher. We used to believe that when you have trees or green spaces, we could remove the particles or remove the pollution by deposition or absorption. But actually there are modeling studies, observation studies, including our own studies, that demonstrate that this is not the case. What you can see here, this is the pollutant concentrations, this is the distance from the road. We can see, when you get about 5-10 meters, your pollution level will be substantially reduced already. And if you look at the deposition effect, which is this kind of a yellow areas, the deposition effect is negligible. It's a really, really small, contrary to what most people might have thought before. But if you create a barrier, like dense trees, spark trees, open field, that's where you can see the huge benefit in terms of creating a barrier between the pollution sources and the area where people are living or working or enjoying their lives. And that is the benefit you will see. So the green infrastructure, the important thing is that they are not reducing the pollution, but they create the space between the sources of pollution and the humans, where the pollution does not penetrate to these areas. It takes longer and it will be diluted, much diluted while they have been reaching the humans. And so by having those could really benefit air quality. It doesn't solve the problem, but it's a short-term solution at least. Now, let's have a look at the other things like a low emission zones or clean air zones. This is the Birmingham clean air zone, which is the Rain Road. We have clearly seen that this has not been reported, or it has not been published as well. It's some really new studies we have done. So this is before the clean air zone was in place. This is after. This is what we predicted based on our model. This is the actual normalized concentration. Essentially, you can view that as the real concentration. And we can see the clear benefit of the clean air zone in terms of reducing the pollution levels, both from the Rain Road, which is a bit surprising because Rain Road, you don't have that charge on a Rain Road, and within the clean air zone, particularly in the clean air zone, we can see a much bigger impact in terms of reduced nitrogen dioxide concentrations. And I think really finally, the net zero cities, they would have deliver air quality co-benefit, and it's really complex. And we know in most cases you will deliver benefits. How big the benefit is, we do not know yet. It's something that we are working on. But what we do know is it will mostly deliver a better air quality. And finally, avoiding unanticipated consequences. This is from the State of Art 2020 report. This is a PM 2.5 exposure, and this is the social demographic index. You can see those developed countries, the high income countries, where have a much lower PM 2.5 exposure, where those less developed countries have a much higher pollution levels. Now, if we start to think about, okay, let's try to reach net zero, which is and by removing heavy industries back to the third countries, but to the developing countries, our air quality will be better, our emissions will be lower, but what that generates is inequality in air pollution, where you can see the pollution levels will be higher, and by the end of the day, the total emissions doesn't change. So if we're only, so some of you might know, or many of you might know, there are different scopes of net zero. So mostly institutionally or by a particular city, we're talking about scope 1 and 2, but the scope 3 is not included in most of the net zero pledges. So what that happens is, if we start to focus on ourselves, say, as a particular organization, ignoring the lead of importing products from other countries and air transport, etc., and the power, etc., we are not solving the problem. From my point of view, we're just remove the problems from our own city and deliver that to displace that to other places. That doesn't solve the problem. And as mentioned earlier, it also causes inequality. And just one example here is the consumptions in Western Europe and the US caused more than 100 air quality mediated premature deaths in China every single year. And because a lot of this is imported, we're consuming in this country, imported from China, and that created pollution. That pollution have killed more than 100,000 people per year. And that is a massive number. But the other thing to consider is there are unanticipated pollution problems if afforestation and biofuel protection could generate biogenic volatile organic compounds, which create ozone pollution and airborne particle pollution, and that could kill people and impact the plants and crop. And if we start to use it, okay, well, let's not use fossil fuel, let's use biomass. And yes, that probably is not going to create more greenhouse emissions in comparison to, because the biomass burning, it doesn't include in those greenhouse emissions, but we just include the PM 2.5, which has become our problem in Birmingham and other UK cities. In summary, we need to embed urban design with air quality strategy, and the better street designs could deliver a cleaner air. And by extending the distance between the pollution sources, we could also reduce personal exposure and improve health. But ultimately, what we really need to do is to reduce the emissions, both greenhouse gases and air pollution emissions, not just try to use an urban design to deliver those benefits. That's not sufficient. Yes, we need them in the short term. We need to consider those factors, but ultimately, if we don't cut the emissions, we're not solving the root of the problems. And what really surprised me is sometimes we see companies or politicians are talking about ways to they're talking about the ways to clean up the air. They are not talking about the ways to cut the emissions. They say, well, let's find ways to clean up the air. Let's build a huge tower to clean up the air. It's just not going to work. The air is so much, you can't clean up the air. You have to start to cut the emissions from the sources. Anyway, thank you very much for your attention. That's all from me.